Wil jij ook werken aan echt succesvolle apps en nog heel veel andere ontwikkelingen die vandaag en morgen het verschil maken?
Do you want to challenge and be challenged?
We zoeken altijd nieuwe developers.
So, will you join us?
Check onze site.
Welcome back with Future Tech, the Masterclasses, and now we joining is Scott Hunter. Well, he's introduced already, so Scott, the floor. Well, there's the imaginary floor is yours.
Thank you very much. I'm so excited to be here today at Future Tech. For folks that don't know me, I am Scott Hunter. I am the Director of Program Management at Microsoft on the .NET platform. My team is responsible for building .NET, and so today I'm here to talk about microservices and cloud native. So let's just get to it because we don't have enough time. This is something I always start with. It's kind of fun to me. I joined Microsoft in 2007. Back then we only had desktop and web, and since then we've added cloud, mobile, gaming, IoT, and AI, and we like to think that .NET is the best platform for building all the types of apps. If you ask about, how are we doing when it comes to the health of the product, we shipped .NET Core in 2017, March. And since then, we've added over 1.5 million .NET Core developers to the .NET platform, which I'm super excited about. Stack Overflow, they do a survey every year on developers, and .NET Core was the most loved framework both in 2019 and 2020. We open sourced in 2014. And we're in the top 30 highest velocity OSS projects, which is pretty good considering we open sourced a little late. C# is the top 5 language in GitHub, and performance has been a key tenet of .NET Core from all the way from the beginning. And today we're 7 times faster than Node, we're faster than Java, we're faster than Go and Rust in many cases. And so the intent being, if you choose .NET, you're going to have the best performance. You might ask, how big is the ecosystem? Well, we have over 5 million .NET developers that are using the Visual Studio family. If you're not using Visual Studio, we don't know who you are, but we know we have at least 5 million of those. We added 1 million last year, and of that 1 million, 600,000 of those were .NET Core developers. And then, .NET Core brought the use of Linux to our product, and which is a topic that we'll use today as we talk about cloud service and microservices. And we have over 2 million publishes to Linux in our Visual Studio tools. I'm super excited to announce that just yesterday we released the release candidate for .NET 5. .NET 5 is the next generation of .NET Core, and its version 5 was chosen to be a bigger number than .NET Framework 4 because it's the future of the platform. And there's a bunch of cool features that come in .NET 5. One is single file applications, which I'll do a demo of in a little bit. You can make smaller containers as we talk about cloud service and containers and stuff. Web and cloud investment. There's a whole bunch of work in the cloud space, and I'll dive into all the things we're doing there. We've added support for Windows ARM 64. We've supported Linux before, but now you can actually run .NET Core on ARM 64 on Windows. And our perf improvements keep coming, and we have new C#, F#, and other language features coming as well. So there's a ton of new capabilities, and all this is going to RTM on November 10th. I'll talk a little bit about performance. We always are striving to make .NET faster, and so you can see here that on Linux we've increased socket performance by over 30%, which is pretty cool. One of the benchmarks that we use our tech on is called Tech Empower, and we lead in many of the benchmarks. And JSON serialization is one we were not a leader in, and you can see we worked a lot between .NET Core 3.1 and 5 to add basically about 20% performance improvement and to bump us into the top 10 in that benchmark. If you're serializing large collections, you can see they're 3 times faster, and they're now 0 alloc, which means your app will just run faster. And probably the most exciting for me, and this slide is a little off because this slide was done with a preview of .NET 5. And you can see that our gRPC, which I think is like the future of WCF. It's a modern replacement for WCF that works fully cross-platform. So you can write a gRPC server in .NET, and you can call it from Java, you can call it from whatever tech. And you can see here that we are faster than Java, we are faster than C++, we are faster than Go, and we're a hair behind Rust. But my team thinks that by the time we ship in November, we will actually caught Rust and will be the fastest stack here. And so it just goes to show you that as we grow the platform and add new capabilities, we want to make sure that we're the fastest in those techs. And so let's just, the talk today is about microservices and what are microservices. I like to think of it this way: is historically what we've done is we have built monolithic applications. And so you can see there's this application in the monolithic column here. And the way I scale it is I just add it to more and more machines. At some point, it might actually have a limitation that I can't scale it anymore because maybe it depends on a backend database or something like that. And the other problem with monolithic applications is typically your organization all has to work together to ship one of these things, which means if one team is got the front end updated faster than the back end, they have to wait for the back end. And so it ends up slowing teams down. And so in many cases, one of the benefits of microservices is breaking your application up into pieces that can all ship independently. Now, another cool part of microservices, as the slide shows here, is as I put this on the machines, I can put various parts of those apps on those machines. So instead of putting only a single app on a machine, now I can put multiple apps and spread them across the ecosystem there. Typically, microservices run on containers. And as you can see here, historically what we do is we basically we virtualize the hardware. That's what a virtual machine does today. You put the OS inside of there, you put the binaries and libraries of your framework in there, and then you put your application on top of that. In the microservice world, instead of doing that, we actually remove the operating system from there, and all we do is we virtualize the app. So the container will only contain your binary, your framework and your application, and a Docker file will actually describe what OS dependencies and stuff are. And then we get some benefits from this. If you see here, in a traditional VM kind of environment, I've got my hardware, my host OS, my hypervisor, and you can see here that in some cases, I don't fill up the actual hardware because, what I'm going to do is I'm going to stick an application onto this virtualized hardware, and then there's a gap there. Now, if I switch to containers, I get this new benefit. Now, if you look at the diagram, it's all virtualized the same way, where I've got, a couple containers running. But what I can do here in containers, I can say, you know what? I'm going to go fill that machine all the way up. And so I'm going to go take the extra resources it has. I'm going to ship my containers over there. And then I get better density and isolation by doing that, because each of those containers cannot talk to each other as well. So you can put more than one app inside of a kind of a VM in many cases, and they're isolated from each other. And so it really increases the way that you can scale. And of course, as you saw here, I decommissioned the unused resources because they weren't needed and saved that machine. As we look at the ecosystem, by 2022, over 75% of the global organizations will be running containerized apps in production. So this is a trend we see in the industry that's going forward, and we want to make sure .NET has a great place here. What's behind this growth? Kubernetes is the primary mechanism that's being used to drive this container mechanism. So you can put a container into the cloud yourself very easily. But what Kubernetes does is it manages those containers for you. And so you get some benefits there. And you can see a bunch of global companies, Pokemon Go, Spotify, eBay, are all doing Kubernetes today. People also like it because it's vendor neutral. Using Kubernetes does not mean that you have to use Azure. You can use AWS, you can use VMware, you can use Red Hat. And then the cool thing about it too is it's community supported. And so all of us are kind of rallying around this. And so you can see here, this is a complicated diagram, and I'm showing this on purpose because I want to show you in a little bit how .NET can make this all so much simpler. And you can see here that there's a controller, and master nodes make sure that everything is balanced and working right. There's tech to make the things talk between each other. But you can see there's this is complicated. When we, the .NET team, first looked at some of this stuff, we were like, our brains imploded, and we're like, is this something that only my IT team can do for me? And I just put the container somewhere, and they manage this. But I'm going to show you in just a few minutes how easy you can do this locally on your machine, and you can publish this up to a cloud if you want to as well. Okay, so let's talk about the cloud native investments we are making in .NET. Some of these actually shipped in 3.1, but anything that shipped in 3.1 is better in 5, I can tell you that. So REST APIs, we want to have the best support for REST APIs, and so we've added support in .NET 5 for Open API. So when you do file new web API, Open API is now a checkbox. It is a spec, a standard that describes your API. And from that Open API, we can give you development tools, and we can give you client generation, and I'll demo both of those. We also have added the support to publish a REST API to Azure API Management. So if you want to manage that in the cloud. As I mentioned earlier on the performance slide, gRPC, that is a modern replacement for something like WCF. You want to have contracts just like you have in WCF. But the cool thing to me is gRPC is vendor neutral and platform neutral. So your APIs, your gRPC contract-based APIs, they work on all the platforms. .NET can call a Java gRPC, and Java can call a .NET gRPC, which I think is super important. And the same tooling that I'm going to show for REST APIs exists for gRPC. The next thing is we talked about Linux. I showed those 2 million publishes to Linux last year. Well, we have now added support with Windows Client 2004, something called WSL2. It stands for Windows Subsystem for Linux 2. And that lets you actually run Linux on a Windows machine. And we built full support into Visual Studio, so you can actually run your .NET projects in Linux on your Windows machine at full performance. The next thing we're working on is smaller single file applications. Many of our developers like to actually deploy their containers with just a single exit with no .NET in it. And I'll show you how, with the tools in .NET 5, you can build a single exit that contains your entire application and includes .NET. And it's actually very small. And I'm going to show one of the C#9 features called top level programs. This also reduce the size of the amount of text you have to actually write. And then finally, I think the most important thing I'm going to show today is Project Tye, which is a way of building microservices and orchestrating them and being able to deploy them to the cloud. And a lot of cool stuff's going to happen there. So this is Project Tye. And I'll give you a kind of a quick overview of what this is. So this is if you built traditional .NET applications, let's say a desktop application, it's a single application. Maybe you built a web application in the past. It's a single web application. As we move to this microservice containery world, and you break these apps up into more pieces, you can see here I've got a front end app, and it's got 3 services. And in some cases, a service has to talk to another service. Well, how does that work? And so one of the things that Tye will do for me is it lets me not have to worry about the IP addresses and ports of all these pieces. And I'll show that in a little bit, because how this works locally on your machine, well, once you go to the cloud, all those ports and IP addresses are going to change. Do you want to go put that in configuration and try to keep it all in sync? No. With Project Tye, we can manage that for you. The next thing is, each of these services might have a dependency. Let's say the top service needs to use a Redis cache. Well, do you want to try to install a Redis cache or SQL Server or all those things on your local machine? You don't have to. With Project Tye, you can define in a single file what services you need. We'll pull the containers and run them all for you without any Docker files. And so it also means your local environment is very replicatable to other developers and to the public cloud. The next thing is, if you're running this crazy scenario where you can see here, I've got 4 applications on my local machine. Well, our tools today aren't great at starting 4 applications and managing them. The Project Tye is going to fix that. It makes it very easy to run all applications at one time, to debug into them, both locally and in containers. And then finally, another cool aspect of Tye is as you build a .NET project today, a web API, for example, how would you find the logs if you're running more than one of them, or even one of them on your local machine? Well, for the first time ever, we've introduced a dashboard that makes it very easy to find those logs and run that application, and I'll show that too. And then finally, that was 4 pieces. How did I take those 4 applications and upload them to something like AKS, Azure Kubernetes Service? And that's something else that Project Tye can do for you, and we'll demo that today too. So let's get to some demos for a little bit, and then I'll come back to a few slides and try to take some questions if I can. So let's close that out. And the first thing I want to start with, I'll just launch a new VS to start. Make sure I've got everything going here. And I'm going to say create a new project, and I want to show you the web API support that we've added in .NET 5. So I'll select a web application here. Create. It's going to offer me my choices of types of applications. Notice I've got 5 selected up here. And the one I want to really talk about today is I've got this new check mark for enable open API support. And that's that metadata that lets us make it easier to debug your applications and to tool around your application. So what I'm going to do is just close out, because I've already got this project created for me. And here I am. This is exactly what would have been created if I had finished that wizard. And the big thing that you see different here is I go look at my packages. Swashbuckle is added by default here. And so let's take a look and see what capabilities this gives. This is just a default ASP.NET web API. And there we go. And so I'm going to run this application. Now, normally, what would happen if I tried to run a web API is I would get a 404 because there's no web app there. But because we've added that open API, now I get this amazing dashboard. You can see my API is very simple. I've got one API called Get Weather Forecast. I can press the button. I can say try it out. I click execute, and all from the browser. You can see my weather came back here. I can test and try my API. Even cooler, I can click this link here. Don't forget this link. Our user studies show that people do miss it. I can click that link, and this gives a JSON representation of my API. And what I can do is I can save that. I'll stick that in my download folder. We'll overwrite that. I'm going to save that because we have tooling in Visual Studio and from our command line both where this enables you to do more with your APIs. Before I get to that tooling, I want to show one more cool thing is sometimes that web interface might feel a little heavy. And so that same code also enables what I call the HTTP REPL. This is something that we don't have installed by default yet, but we will get it installed by default before long. And what this does is I can take my API and I can run it. And instead of having to go and have that browser pop up, now right from a command prompt, I can see my API. Notice I can do an ls or a dir and find that. I can actually go into the folder of my API. Now I'm in there. I can just call get and get the data. And so the hope for this is this makes it very easy to put breakpoints in your code, run your API and test it, all without having to run a client app or something else on top of it. Now let's show how this can actually make my tooling even better. So I've got my API, but what if I want to call it? How hard is it to call this API from .NET? It's amazingly easy with .NET 5. So I'm going to go here and create a new project. We'll create a console application. I'll do next, and we'll call this API demo. I'll click create. This is just a regular console project, not a big deal. Now what's new, and some of this tooling is new in 3.1, but having the open API automatically in your project is brand new in 5. I can click on my project, and just like I used to be able to do in the WCF world, I can go add a connected service. And notice that there's this option right here for service references to open API or gRPC. I'm going to click add. It's going to go look, do I have an open API? And I do. And I'm going to browse to my download folder here. Grab that open API spec. Click finish. It's going to go add a NuGet package. It's going to go look at that open API. It's going to generate some code for me. Okay, so if I click this ellipsis here and go view generated code, actually it needs to be built first, so let's let it build. Okay, click that ellipsis, view generated code. Now you can see here, I've got a bunch of code all written for me. This is the code you would normally have to write yourself to call that REST API. Yuck, I don't want to do that. So now it's as simple as going back to my program CS and adding a little bit of text here. So I'm going to cheat. I've got a little snippet. We'll fix that. First off, it needed an HTTP client, and then this is the generated code for me. So I knew up the Swagger client, giving it my HTTP, and that's so I can pass my rules for retries and stuff like that. Now it's complaining because this is an async method, and my main's not async. I'll fix that. There you go. And you can see it generated this code where I can just take the client and call weather forecast. And then it generated the type for me for the result, and I'm good to go. So let's go put a breakpoint over here. And what I'm going to do is go to my solution, go to set start projects. I need to run both solutions at the same time, obviously. The API runs first. Let's get our API to start first. There we go. Now press OK. And now I should be able to F5. I forgot one thing. Let's fix that real quick. Sometimes when I do this demo, I forget to go set the browser back as my default. Let's go do that. Let's run the demo. And I confused it one more time. Let's go select back to run two projects. There it is, start. Start. There we go. So they're both going to run now. So my browser launched. You can now see I'm in the breakpoint to call the API. F10 on the API. Now, if I go hover over this, you can see I got 5 results back. There they are. The type was generated for me automatically. I can step right through here and write those results out to the screen. Go back to my terminal. You can see the results coming out. And so you saw in like 10 or 15 seconds, I was able to write a client to call my API. I don't have to worry about that code anymore. And so we think this is a tremendous feature that brings some of the WCF-isms, but you're still using real REST and just like you're used to. So I'm going to close that out, and I'm going to switch to one more app real quick. I'm not going to write all that code again, but in this case, I have written a gRPC version of the same code. And so if I look at my proto file, this is a file that describes the API because gRPC is cross-platform. You can see that I've got a type with a date, temperature in both Celsius and Fahrenheit, and a summary, and then I've got a method to call that. And so what happens is you write this file, and then our tools, all you have to do is basically come over here, and notice I overrode this because we generate the server code for you as well, and you just override the method you want to write the code for. And so this is written in gRPC. And then I've got a client written exactly the same way. And I can even show the same kind of thing if I go over here and right click and say, oops, add service reference. It's going to show that same stuff that you saw before. There we go. This time you're going to see that I have a gRPC configured. And once again, I can go look at the generated code, and you can see we wrote all this code for you once again, just to make it where you can actually call the client just like this. New up the channel, which is where you give us the address and the port, new up the client, and this call method on the client. And so, as I said before, we think this is amazing, making it so easy to write server code, and then we'll generate the client code for you automatically. Okay, so I want to show one more cool thing in the client space real quick. Let's bring this up. And I want to talk about developing on Linux. So what I've got here is I have an ASP.NET Core web application. And what I want to do is I want to run this on Linux, because I know in production I'm going to write these, I'm going to turn this into containers, and this container is going to run on a Linux machine. But I'm developing on Windows. So notice here that I wrote some code in my application right here that basically spits out the OS version. Now what I'm going to do here is just show you what the default experience would be if I Control F5 this application. You can see it says, welcome, you're on Windows. Yeah, that's kind of what I expect. Now, what I can do is I can take the drop down here and I can select WSL2. And that's the Windows subsystem for Linux. And now that same Control F5, the app booted up. Now it's running on Unix. So it's that easy to switch from Windows to Linux on my machine. And now that I've done it once, it's really fast. Boom, you can see how fast it came out the second time. You can develop on Linux just about as fast as you can develop on Windows. And this is full support. If I put a breakpoint here and I F5, you're going to see the breakpoint's going to hit here. Whatever comes up. And there I am sitting at the breakpoint. And so the development is exactly the same as it would be for Windows, except you're doing it on Linux. And that's how easy we make it to do this on your machine. There's one more thing I could have done here as well, is I can also right click on the project and I can add Docker support. I'm not going to finish it here, but I can select this and I can run it on containers using Docker if I wanted to. But you just saw, I don't need to do this. I can run it on WSL2 super, super fast. I'll do one more quick demo and we'll get to Tye, which is my favorite part of the tech. So let's load up Microservice 3.1 and let's load up another VS. And so I want to show another feature that we have in 5. It started in 3.1, it got a lot better in 5. And this is our support for building single exes. So in this case, I've got a simple .NET microservice. And so this is showing the microservice using .NET Core 3.1. It's about, let's take the space out there. It's about 23 lines of code. But something you might not have seen before, if I right click on my application, I can click publish. And what I'm doing here is I publish to a folder. I'm not publishing to the cloud. But if I click edit on my publish settings, I have some new settings that you might not have seen before. One is, and I've already set this, self-contained. I can choose to have .NET on the machine, or I can choose to select self-contained, at which point we'll actually put .NET directly into your application. I can then open up these file publish options here, and notice there is produce a single file. That tells us to make your application have .NET in it, and then shove .NET and your app together in the same file. And then I also say, get rid of the parts of .NET that I don't actually need. This makes the smallest possible executable. And so if I run this is a .NET Core 3.1 project. Let's see what happens here. So it's running. It's going to be linking here. In a second. There is a little bit of work here because what we do is we take the application, we put .NET in it, we get rid of all the .NETs you're not actually going to use. I can click this little button here. And from that, I can go here, go into the publish folder, and you see I get about a 41 meg executable. And so that contains your entire application. Cool. So let's, I'll just close this app out. And I'm going to switch to my 5.0 version. And first thing I want to show is, notice it's not 23 lines of code now. It's just 16. There is no main in here anymore. This is using a feature called top level programs, where you can reduce all the junk and just write your app. And so if you want to write the smallest microservice, this is how you do so. Now I'm going to take this app and do the same thing I did before. I publish it to a folder, but in this case, I'm going to go and once again show the same settings. But .NET 5 is a little better than .NET Core 3.1 was. Publish options, single file, trim unused things, self-contained, perfect. I'm good to go. Let's click publish. Give it a chance to finish all this. And so what you're going to see, as I mentioned before, size. We really care about making projects smaller and smaller and smaller for these container microservice worlds. And so once this completes, there it goes, optimizing for size. I'll copy the path. I will open up another file explorer. I'll stick this one over here. I'll stick this one over here. I will paste the path in. And what I want you to see here is this executable is 21 megs. The 5.0 one, this one is 41 megs. So you can see .NET Core applications or .NET applications got 20 megs smaller. You can now build a 20 meg ASP.NET application that does not require .NET to even be on the machine. Okay, so we close that out, and let's switch to Project Tye. So Tye is one of my favorite features in .NET that we're working on right now. And so I'm going to do open up VS Code. And the first thing you're going to notice here is I've got a microservice application. There's a front end application and a back end application. Now, this brings all kinds of challenges to me. You know, I could go the front end and I could do something like .NET run. This won't work because this is what a typical developer might do is I'm just going to go start the front end application. I have not started the back end application. And so when I run this and try to run it, I'll get exactly what I expect. The app's going to crash because it can't find a back end. Yuck. Okay, so how can I fix this? How can I make this a better experience? So I will go into, let's just jump back up here a little bit. I can go into VS Code, I can go to the terminal, and I can do something. I can do .NET, not .NET. What am I thinking? I can do Tye run, and in my case, I'll do -- watch. And so what Tye's going to do, it's going to go look at my folder and find all the .NET applications underneath it. It's going to build them all and launch them all in a portal. So let's scroll up and grab, well, I don't even have to scroll up. I actually have an extension installed in my Visual Studio and in my VS Code that actually knows about Project Tye and knows that things are running here. So let's give this a second. There it goes. I can click the dashboard, and now I get this brand new dashboard, which you've never had before. So I'm running more than one application. You can see my front end app, it's a project. My back end app, it's a project. I can look at the logs for each of these apps. It's kind of cool. I can click on the front end. I can see the perf counters. So we're giving you a bunch of extra information you've never had before. It's all been there, but we've never given you the way to easily get to it. Now, if I click and then we show you the links to each of the projects that's running and the ports they're running on and all that magic. Now, if I run it, it's still going to fail. And it's going to fail because the front end and the back end don't know how to find each other. So let's go back to my code and let's go fix that. So let's go look in here and take a look at this. This is what you likely are doing in your apps today. I've hard-coded localhost and some port. Well, that's going to change in the cloud. Yeah, I could put it in configuration, but that's hard to manage. So I'm just going to comment that out and use the Tye way. In Tye, I just say client.base address configuration get service URI. I give it the name of the backend, and I'm done. And I can save that. So let's see if it actually refreshed. It refreshed, then, yep, it did. Look at that. So now I actually call things by name instead of calling them by ports and IP addresses. And we make sure that will work locally and work in the cloud. So that's pretty good. So the app now runs. I can show some other cool things. What if the app needed more tech? What if I needed a Redis cache for some reason? So let's do this. What I'm going to do is I'm going to type Tye init, and that's going to create a new file in my project that actually, something that happened automatically before. It created the YAML file with my front end and my back end already here. Great. That's what was happening automatically when I did Tye run, but it wasn't visualized. Well, now that I've actually created the file, I can go do things like this. This app needs a Redis cache. And so in this case, instead of saying project, I say image. And that means it will go and grab the image from the container registry. And then I have to give it some information, some parameters to boot a Redis up to boot it up. Now I've not written a Docker file. I've not installed anything. So before I change anything else, let's save that. I'm going to go back to my project, and I'm going to go add the Stack Exchange client and configure it. So I'm going to go make the app be aware of Redis. And it's playing here, which means I might need to go into my CS proj. I do. And comment that package reference. Restore. So I'm good to go there. I've now added support for Redis to my application. And then once I've done that, I need to go a little bit further. Let's make the app actually understand so the error goes away. I'm going to take my file, and I'm going to put the entire thing in a tag helper that knows about the cache and says, hey, cache all this for 5 seconds. There we go. So now if I come back here into my terminal and I do like a Tye run again, this time more stuff's going to happen. And once again, as I said before, I've not written a Docker file. I don't know those things. We're going to let the project do this for me. So you can see it's actually downloading Redis right here live as part of this talk. There you go. And the nice thing is it's not installing Redis on my machine in a way that I have to go uninstall it. It's just ready to go. So let's go up here. Let's do a refresh to my dashboard. Now notice that a container shows up. Amazing. And I can even view the logs and stats of the container. And so I can click the app, run it again. And now these numbers aren't changing as I refresh the browser because they're all cached for 5 seconds. And so that easy, and with 2 or 3, 5, under a minute, I added Redis to my application. I restarted my application. I didn't have to go install anything on my machine, and I'm good to go. I want to show one final piece of Tye before I get to the end of the talk here. I'm going to go stick one more thing inside of here into my Tye file. And this is basically what we call an ingress. Stick it here. And so what the ingress will actually do is the ingress is how I can actually make the port be exposed on the public internet. And so just to check if things, make things are still good, I'll just do a Tye run again one more time. And we're going to integrate all this Tye tech directly into the Visual Studio family. So, I'm doing some stuff in command line. That's just because we're developing this. Even though you can try it today, the ingress does show up. I'm good. So let's try the final piece here. And what I'm going to do is I'm going to say Tye deploy -I for interactive. And so this case, what's going to happen is Tye is going to go try to take all my tech and upload it to the cloud, into Azure. So let's go to my Azure Kubernetes service. In this case, I don't need the Kubernetes service. Let's go home. I need the cache that I have here. I have a Redis cache in the cloud, so I can run this app in the cloud. And what I need is I need a connection string. So I'll just grab this. Actually, I don't need that connection string right now yet. Let's go back to the overview here. What I need is I need the name of mine. I'm losing my mind actually here. Let's try one more time here. Let's go to my container registry where we're going to upload all of these things. I would grab the URI for that, paste that in. Now what's happening is without me writing any Docker files, Project Tye is taking all of my app, creating container images for them and uploading them to the container registry. Now, it also knows that there's a Redis, and it knows that I need to probably give it a connection string for a Redis in the cloud. And that's where it was earlier when I was around the wrong place. So let's go to my Redis cache. And what we'll do is we will scroll down to access keys, and I'll grab this access key here, stick that in. And now it's taken all of my components, uploaded them to the Azure Container Registry. It just booted the application up, and that's fast. I took a local app with 2 components and a container and uploaded them to the cloud. And I should be able to do in beta, sometimes I have to run this command 1 or 2 times. I got it to work the first time. This is a public IP address. Go up here, paste this into my browser, and there the app is running in Redis. Running in Azure Kubernetes Service. I was able to go from local to the cloud that fast. So let me jump back to some slides, and let's close out a few things. I want to just close out saying the .NET 5 tech I showed you, it all is going to ship on November 10th. We ship .NET every year now. So you can see here, 3.1 came out this last December. .NET 5 comes out this November. Every other year is a release, and every other year is a long-term 3-year supported release. The hope here is to be predictable and easy for you to understand. Now, on that November 10th, that is also where we're going to launch the next version. As I said, .NET 5 is going to launch on that day, and so we'll have our own conference that'll happen over 3 days. It's the .NET launch. It'll be half Microsoft, half the community, and please come check us out on November 10th for the launch of .NET 5. And then with that, I want to say thank you for having me. Thanks for joining, and I'll see if I can take a few questions.
Great session with a lot of demos, and we like that as nerds, as devs. Slides, pictures are fine, but the demos are better. And oh, there is a question, I think. Yes. Are the Docker images that get configured for you also manually? Can you also manually configure them?
Yes, yeah. So we will give you the ability to, if you want to write Docker files and stuff yourself, there'll be a backup where you can do that. The real intent, though, in many cases, is you don't need to write those things. Okay. And so we support both. Yes.
Oh, and can we expect HTTP REPL make it into the tooling on some point?
Yes. So the HTTP REPL, I don't think it will make the tooling for November 10th, but I would hope that by early 2021, one of the updates to Visual Studio after that, it'll make the actual tooling. We're pretty close now. Getting the API projects to automatically have the open API was the first step, and that's what comes on November 10th. It's in preview now. But yes.
Because many of the people found that a very interesting software tools to have. And
on the .NET 5 launch, I'll just add one more thing there. On the .NET 5 launch, we will have a blog post that'll show you how to install that REPL yourself before we actually get it built in the product.
Cool. Okay. Are there any more questions? Well, a lot of people say it's amazing and excellent, and there was self a hoo on the release candidate of .NET 5. So that's great. And the colleagues of Microsoft, Susanna, already had in the Discord channels a lot of information about the documents on Tye and on the .NET Core 5. So that's handled over there. And well, thanks for doing this talk for your early morning. For us, afternoon.
Well, hopefully in the future we can do it in person again and not remotely. So
yeah.
that's
our hope and belief also. But yeah, thanks for the opportunity to be here. So you are visiting our session. So great, and we will all log in on the .NET Conf later this year in November. There's one small remark. Microsoft Tye seems super excited, and it
awesome.
Was indeed a good talk, as we already told. Thanks for this so far, and that makes the end of today 1.
Tomorrow there will, of course, another day, and tomorrow will be day 2. And during that day, we have also a session about gRPC, what already was told by Dennis in the Discord. So please tune in tomorrow again for another day of Future Tech. Don't forget to get also back on Thursday, because then we have our famous pub quiz. I will be your host, samen met Stijn, and there will be a lot of good prizes to be win. Once again, thanks to ABN AMRO and co-sponsor Microsoft for sponsoring this event. So see you tomorrow.